Hello, this video is submitted by Sangitinli Inish Womo of 30 Electrical. This practical aims to study the parallel operation of three-phase alternator at constant load and speed. The parallel operation of alternator are very important in order to increase the efficiency of operation. These are the various advantages and conditions for a successful parallel operation.
This is the circuit diagram for the motor side. The terminal A1 is connected to E1. From E2, it is connected to ammeter to resistor R2, and R2 back to terminal A2. The positive terminal is connected at A1 and negative terminal is connected at A2. For the field excitation, negative terminal is connected to resistor R1 and to terminal F2. From F1, it is connected to ammeter and ammeter back to positive terminal. For the generator, it is connected in star and it is connected to three-phase synchronous meter. We have used two switches here, 3-volt switches, one for generator and one for bus bar. For the synchronization, we have used one dark and two bright method. At the bus bar, it is connected to load, which is connected in star. 3 ammeters are used to measure the 3 current flowing in 3 phases. A voltmeter is used to measure the bus bar voltage. Another voltmeter is used to measure the terminal voltage.
Now moving on to the circuit connection. First, we do connection at the motor side, and this is the circuit connection for the motor side. This is the circuit connection for the field side. Lastly, the circuit connection for the generator and the bus bar side. To start the motor, we have to turn on the switch and turn on the supply. Give the rated voltage supply to the motor, that is 205 for our case, and keep our motor at the rated speed, that is 2000 rpm. And now give the supply to the generator side by turning on the DC source. Bus bar supply by turning on variable DC source and give a rated voltage, that is 400. The bus bar voltage and terminal voltage should match. And we have to also check the frequency. Check the phase sequence of the voltage generator. We used a phase sequence meter. The direction of motion for both should match. That for our case it was both in the anti-clockwise direction. From there we confirm that it has same phase sequence.
After reducing the speed of rotating lamp, we turn on the synchronization and increase the load. And look at the readings from these 3 ammeters connected to 3 different phases. Next, we use 2 dark and 1 bright method. First, we turn on the switch at the incoming generator, and next we turn on the switch from the bus bar. Similarly, to slow down the speed of the rotating lamp, we regulate the voltage at the incoming generator, and then try to switch on the synchronizing 2 dark and 1 bright phase. Again, we try to give load and take a reading from this ammeter. The readings from this ammeter should not exceed the rating of the incoming generator. Now let's see what happens when one of the source is disconnected. First, if we put off the supply from the bus bar, we can see that the bulb is still glowing, which shows that there is continuous supply from the generator. Now let's turn on the bus bar and turn off from the incoming generator. The bulb is still glowing here. This shows the bus bar is supplying continuously. Let's use these 2 switches and see what happens when the supply is disconnected from 2 different sources. First, if we turn off the switch at the incoming generator, the bulb is still glowing. This shows there is continuous supply from the bus bar. Let's turn on the switch at the generator and turn off the switch from the bus bar. Here also, the bulb is still glowing. This shows there is continuous supply from the incoming generator. Finally, after the experiment, close the switch at the synchronizing, then next turn off the switch from the bus bar side. Turn the switch at the incoming generator off, then slowly reduce the voltage at the bus bar side and put off all the switches.
Lastly, throughout this practical, we have learned that there are various advantages for operating 2 or more alternators in parallel. By operating alternators in parallel, it would be economic, machines will be able to operate at full load, and maintenance and repair will be possible. Hence, we conclude that it would be better to run 2 or more alternators of smaller rating to meet the load than to run 1 alternator of larger rating. This is all for the video. Thank you for listening.